It is not unusual to hear how geothermal source heat pump systems are very energy efficient. But what is it that makes them so efficient? Both boiler tower and geothermal systems are basically the same heat pump equipment, and the COPs are very similar when rated at the same conditions. A geothermal system's summer design conditions are close to a boiler tower system's, but when the winter comes, the design temperature is often much lower. While this is true, geothermal systems do not have a boiler or a cooling tower. There is just a large water pressure drop in the ground loop that requires a large pump of horsepower. Any advantage of the system is closed loop water source heat pump design. The concept allows energy that is not required in some areas of the building or a cooling load to be moved by using areas that do not require energy or heating load. For many applications, water source heat pump systems match or exceed the performance of even the most sophisticated VAV air systems.
In addition to the energy operating cost savings, geothermal systems offer many other advantages. Because there are no cooling towers, boilers, there is no need for sump heaters, tower water, chemicals, and makeup water.
Each water source heat pump is close to the zone it serves, avoiding the large duct runs associated with the air systems. Individual power metering is possible, allowing occupants to control and pay their own energy costs.
Water source heat pumps are easy to service and do not require specialized training. The owner has many more options regarding maintenance and service. The refrigerant charges are small, which help minimize safety requirements within the building.
Heat pump systems with properly designed ventilation systems offer a good solution for indoor air quality, or IAQ. The units can be supplied with double-sloped, cleanable drain pans and closed-cell insulation. A proper ventilation system, along with the heat pumps, can control moisture for a good IAQ.
The thermal conductivity of the soil at the site is required to estimate the ground loop performance. For large projects, the soil should be tested. The advantage to testing is more accurate soil data will allow the designers to minimize safety factor and reduce the number of rules.
Ground testing provides the designer with accurate information on the thermal conductivity. With this information, the loop design can be optimized in most cases, and the length of piping reduced. If the bidding contractors will test bore data and drilling conditions on the site, this will remove some of the uncertainty, and they may provide a price with less of a hedge on it. The tests are generally conducted by drilling a borehole or adding a loop. Hot water from a portable electric heater is circulated. A data log is running over 48 hours, and the energy absorbed by the ground is measured. From this, the conductivity and diffusivity can be calculated. Ground tests can cost over $2,000 per borehole, depending on the site conditions. They make sense for projects over 50 tons, or if the site conditions are not well understood.
Undisturbed ground temperatures is best obtained from local water wells, logs, and geographical surveys. Figure 9 shows the approximate groundwater temperatures in the USA. The undisturbed ground temperature will remain consistent throughout the year below 30 feet, above 30 feet. The ground temperature will change with the season.